Broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to this special webinar focusing on home build projects with a focus on entry-level product design assessment and development. My name is Jonathan Evans. I'm an application engineer for CompoSIDE, and I'm joined here with my colleague Sam Ashton. Hello. Today's session should last around 45 minutes, and we'll leave some time for questions at the end. If you have any questions during the webinar, you can input those in the GoToWebinar interface on the right-hand side of your screen, and we'll go through those at the end as well. This webinar is being recorded, and we will upload it alongside our previous webinars and tutorials on our YouTube channel. So if we go through what we're going to run through today, we'll briefly go through an introduction to composite design, composite materials and process selection. Testing and certification of composite materials can be a bit of a tricky subject, so we'll run through that very quickly. And then we'll move on to a design approach in CompoSIDE, a live demo, and focusing on a case study of an architectural panel to show you how things work and give you some ideas on how you can base your application in CompoSIDE. And then, as I mentioned, we'll go through some questions and answers towards the end. So just before we get started, just to let you know that you can sign up for a 30 days free trial. You can find that on our website. Very easy and quick. Within 15 minutes, you can be working and engineering within CompoSIDE. So as the title of the webinar suggests, this webinar is going to focus on affordable entry-level composite design analysis for your composite projects and how CompoSIDE can aid you for design and manufacture. The end goals are to assess the composite feasibility, whether we're looking at cost versus weight versus mechanical properties for a range of different materials and manufacturing processes. Having the ability to compare solutions between original metallic structures compared directly with a range of composite solutions, and be confident that our structure works, making sure that we're looking at the appropriate failure modes and applying the appropriate load factors. So how would you approach this problem efficiently with a minimal knowledge of composites? Before we start, the main questions and challenges that we have kind of asked to us on most days is the questions that you can see on the screen. What technology and materials do I use to select to achieve a lighter solution? How do I assess my composite structure or composite concept? And what are the associated material quantities? These are all factors that lead from the questions: how much weight can I save? How much stronger or stiffer will my resulting structure will be? And how much time can I save? So it's all a careful balance between those three factors, so cost and time, strength and weight. Now, there are some rules of thumbs that you may want to use. For example, the black metal approach, which is just comparing the weight of a metallic structure and asking for the same weight in composites. This is certainly not favourable to composites and very wrong in the vast majority of cases. So today we want to show you that you can answer these questions yourself with greater accuracy with CompoSIDE in just a couple of engineering days. CompoSIDE can be used in all stages for the product development, from designer to manufacturer to end user. so that from the engineer's base point, you can design and develop your products within CompoSIDE. Your manufacturer, if you pass that design on, can then make modifications or material substitutions very quickly and easily within CompoSIDE. And as an end user, if you're receiving a product, you want to know that your product is safe to use and that it's optimized, it's lightweight, and stiffness meets your requirements. So you can perform a due diligence. So I'll now hand over to Sam, who will take you through selection approaches for composite materials.
Thank you, John. Okay, so there are a few key questions we need to answer during the design process. So as a starting point, we really need to get our heads around material properties. These are many more factors to consider when dealing with composite materials compared to metallic materials. However, we deal with these is not always obvious. However, in CompoSIDE, we can help with that. There are a wide range of different components that make up composite structures, so finding the optimal combination of these is the basis for composite design. The choice of materials is also affected by the process, so understanding the impact of this is important for design comparisons. With home build projects in particular, obviously we may be limited by the processing methods that may require low equipment costs and don't require high tolerances. Material suppliers do not provide data that is really suitable for design. Therefore, without standard composite materials, we need to do some testing to get properties for the combination of materials we want to use. However, the cost of testing can be extremely high. Depending on the level of certainty we require, there's a minimum level of testing needed before we have enough properties fit for design. If we want to compare different material combinations, we cannot expect it to run tests for each of the choices we have. Just some examples of costs on the screen. So unless we already have an in-house database that includes a vast range of material properties, is there another way we can continue with the design? CompoSIDE's Composite Material Database, CMDB, is a robust dataset that provides those foundations for developing designs. It can give you a starting point to try different materials and processes so we can develop our design rapidly. CMD provides you with those values so we can essentially bypass the testing stage that gathers those initial material properties. This helps us develop designs a lot quicker than we would normally have to do. The database includes a basic range of materials to begin with. However, there's an additional add-on we can include with over 1,200 materials. This can further enhance our design process. Therefore, material testing becomes validation rather than investigation. With over 30 failure modes, composite design requires a higher degree of integration with analysis tools than conventional materials. CompoSIDE is a modular software, so this allows us to link all the aspects of the design stages together. We'll see this later in the demonstration with John. So with the database itself and CompoSIDE, there are different ways we can work with it. We can input our test data ourselves, so if we already have some data, we can put this into the database. We can use reference materials to create new sets of data, or we can use the data that's already in the library. We can also then create combinations using the PlyGen tool, which we'll quickly cover in a minute. And then obviously with this, we can then create our laminate stack-ups that we can use in the design. So in the database, the material data is highly accessible with many data comparison tools and export functions you can see on the screen. These include scatter plots, Excel exports, bar graphs, and many more functions we can use. So with the add-on itself, what will we get? What would we expect? So the data we would get is fit for design. So this includes a complete set of properties that we would need for FEA. So if we look at some of the add-on itself, we've got over 1,200 materials, as I said. And then we focus on the plies and cores, we can have a look at a bit more detail. So with the cores, there's a range of and variety of cores is quite large. And with the CMDB add-on, gives you access to all of these. It's not always obvious how different types of cores can impact the design, but having that data allows you to compare those options. And with the Plies, the Ply library includes many combinations of the inputs shown here. With this, there's nearly 900 different material combinations for the Plies, and we can select any of these in the database. And then using the tools discussed, we can quickly narrow down our selection or find materials that have the best combination of properties that we require. Here's just a scatter plot of a selection of materials, so we can compare different properties and then look at the group of materials that are within our required properties. But if we don't have enough material properties, we can create our own using the PlyGen tool. We can select any combination of fibre, resin and manufacturing type to then create a material that we have confidence in to use for design. Okay, so I'll hand back now to John and we will have a look at a case study.
Thanks, Sam. So as Sam mentioned, there are three main kind of factors within composites. We've got the materials, the process, and the engineering. CompoSIDE caters for these by using the CMDB database, as Sam has mentioned. The engineering is focused on by the use of laminar space, which is our classical laminate theory tool. Section space, which is our 2D analysis tool, and FE space, which is our 3D beam and shell analysis tool. The process in terms of manufacturing and getting data out, material quantities, costs, etc., is focused on by PlyGen, and then we have a reporting tool, which is report space, which grabs all of the data and puts it into one previously formatted file. The connection between the materials process and engineering requires quite a high level of integration between the elements, which means that all of these modules are interlinked together to make sure everything's efficient and you can optimize it very quickly. So for our example, we've chosen a basic architectural cladding panel. I have noticed that you all have quite a wide variation of projects across different sectors. The same workflow and process can be applied for all of these products. So the metallic baseline metallic structure is a 6-meter radius segment of an architectural sphere made of aluminium alloy and weighs currently just over 650 kilos. The goal of this is to analyze the feasibility of a structure using these composites while maintaining the same level of stiffness. It is required to withstand gravity and wind loading, driven by a maximum deflection of 10 millimeters, and obviously ensuring sufficient strength. So let's go through how we would do this in CompoSIDE. First step is to select the materials from our CMDB database. Once we've done that, we can then use 2D sections and 3D models to bring the geometry in using DXF format for 2D sections and step file, or we can create our own geometry within FE space. Now this is really going to form our baseline design analysis. As I said on the previous slide, we've done this, we've put it in PlyGen and report space, and we've got that weight of 650 kilos, and it meets our stiffness and strength requirements. The next step, which is to convert it to composite. So again, back into CMDB to select the materials. But which fiber type, which resin system, and which manufacturing method, you can quite quickly have a look at this in CMDB. We'll go through this in the next step. Section space. So from the original aluminium baseline design, we can directly replace these materials with an equivalent stiffness. Pretty much a black metal approach, which we want to avoid, but this is where we optimize in the next step. So from this, we can generate our section stiffness, cost, and weight properties. And then we have FE space. So we replace our section and analyze with our composite shell. This will then give us our bill of materials and then our report. So in the third stage, which we'll run through live, we're going to use CMDB again to select our materials. We're going to use laminar space to optimize our laminates. We're going to skip the section space part and just focus on the shell. So we'll keep the sections and just analyze with the composites. So if we jump into CompoSIDE, here we have our environment. Our modules work from left to right. So in project space, this is where we set up our project factors, our bill of materials, settings, etc. Then we have CMDB, which is where we have all of our materials. You can see we've got a small selection in this project. If I go into the CS material library, we can have a look at all of our plies, all of our cores. This may take a few seconds because it's pretty big, but that's okay. Okay, so if I just select by cores, apply filters, and you can see that all of these are standard materials. They are driven by companies. So you can see you've got 3A Composites here, a few of other of their competitors. And we can select all of them. So for example, if we want to have a look at just 3A, I can select all of these guys, right click, and I've got a few different options here. So I can compare materials directly in CompoSIDE. Properties for calculation, so I can have a look at all of the properties compared to each other in less of a graphical format, but you can pick out the values a lot easier. I can export the properties for calculation. So if I'm working with a spreadsheet, you can export this to Excel and manipulate the data there. I can have a look at the property scatter plot. And I can also export to ASAComp, Nastran, OptiStruct, and ACP. Some of our clients like to use CMDB just for our materials database, just so they can grab their materials and use it in their kind of advanced FE models. So if we have a look at the scatter plot, we can have a look at density to, let's go for shear strength. Shear strength, where's it gone? Shear ultimate strength. No, not that one. In plane shear strength, here we go. So if you hover over, you can see the material and the density versus in plane shear strength. You can have a look at each of these drop-down menus. So it's quite a good way to compare different materials, different cores, and then make your decisions based on that. So the first step is to select these materials. So if I wanted this material, I can just drag it straight into my project material, sorry. And this just filters it out, so you don't have all of those 1,300 materials clogging up your database for just the projects that you're working on. Ooh, I brought all of them in. Okay, good. So once I've chosen my materials, I can go into laminar space. So in here, I've got all of my laminates within my project. For my aluminium panel, so I can have a look. I've brought in my aluminium panel. This is 4mm thick, which is the original baseline design. I can see the weight and the density of this. but also I can have a look at the engineering constants. So I can have a look at the in-plane, out-of-plane stiffnesses for this stack up, even though it's an aluminium sheet. I can also have a look at the allowable strengths, so the allowable bending moments, in-plane strains, and stresses for this. So if I just have a look at the engineering constants, we want to go for an equivalent stiffness design, so 73,000 roughly megapascals. We want to match that roughly. So let's create a stack up with a carbon sandwich panel. So create laminate family, carbon sandwich, and it's going to be infused. Create. Okay, so it's very easy to bring your plies in. All you have to do is click on ply and core. So let's search for these. I'm going to use quite a bulky ply, so quadriaxial 400, not very optimized, but quite production friendly, pretty easy to lay up and pretty easy to design with. It's fairly as isotropic as composites go, really. So let's add 4 of those plies, and as this is already at 0, plus or minus 45 and 90, I will leave this at the orientation at 0. Okay, so let's add a core in. Choose one of the ones that I brought in earlier. So an 80 kilo T92 3A core, 20 millimeters thick, and add that in. Now, as this sandwich panel is going to be symmetrical, I can use the sequence type to mirror it automatically. So symmetric odd. If I change anything in the top skin, it will automatically be mirrored in the bottom skin. Okay. So if I save and close, what CompoSIDE is doing is now it's just generating the properties. So I can see my physical properties on this first screen. And then I can have a look at my engineering constants. So exactly the same as we did for our aluminium layup. We can have a look at our in-plane, out-of-plane stiffnesses and our ABD matrices. We can also have a look at the allowables, through thickness, shear capability, sandwich stability, and loads, which you can have a look in once you're in your trial. Okay, so that is our laminate defined. Let's move into FE space. So back into our home screen, into FE space. Now what I've done is I've duplicated the 4mm cladding panel, which is our baseline design, just so I have the same geometry, the same loads, and the same boundary conditions, etc. to design with. All I have to do is apply my laminate, run the analysis, and then double check and optimize from there. Okay, so to create a shell, I can just select my surfaces, and then I can add a cylindrical orientation set, which is this one here. Because it's a curved surface, I want to make sure that my plies are going to be laid up or analyzed as they will be laid up in real life. Okay, so add my laminate family. This is exactly what I've just created in laminate space. Add it in, and these are all linked. So I can jump back into laminate space from FE space to optimize it later on. If you want to select or unselect plies, for example, if you want to see how it reacts as a single skin panel, I can just unselect it and then analyze it from there and just tick it back on when I need to. Okay, so I'll save and close and just mesh the model. It's very quick, usually takes around less than 30 seconds, so very efficient in time. Okay, and then I've got my load cases as before, so it's just a working pressure, a wind pressure. and it's supported around the perimeter of the shell. So I can calculate this. So when it's calculating, it sends it off to our server. You can see it's calculating on a server, and then when it's finished calculating, it will come back. Okay, so that took 10 seconds, pretty quick. And now I've got my task here. If I want to lock this and rename it and save it as a task, that's very easy to do. And you can always refer back to it in the future. Okay, so this is our displacement results. You can see that we're 10.6, so we need to increase a bit of stiffness there. And we can also check how we're doing in terms of strength. So we can go into reserve factor shell and have a look at fiber failure, because this is an ultimate load. Calculate, and this will bring back the reserve factor results for each of those plies. You can have a look at it in a bit more detail, but this will just bring back the minimum result. Okay, 4.3, so I'm happy with the strength. I just need to optimize for the stiffness. So if we come out, I can go into my shell, hit edit, and then in my stack, I'm going to increase the core thickness to, let's say, 40 millimeters. So into laminar space from here. And if I double click and just change this to 40, save and close. And then this will bring the new laminate back in. Okay, it's giving me a message saying, yeah, it may have changed. Okay, good. Okay, I've lost my inner skin, so I will just symmetric odd, convert it, save and close. Okay, good. And I can just select these again. So save and close, that was very easy to update my laminate. I can remesh. And then run the load case again, which will bring me another task, which then if I need to go back into them, I can just click on the task and bring back the results. Okay, good. So just have a look at the displacements, 9.86. Okay, so we're in the boundary. That's good. Okay, so that's one of our requirements sorted. When we look at the other requirements, so the other one was weight. We can have a look at the mesh mass properties. And we're at 363.4 kilos. So we're significantly lighter than the previous aluminium structure. Okay. So from here, then we can take it into PlyGen and create a report from this. This will just give us a breakdown of the material quantities that we need to either purchase, and that takes into account any offcuts or wastage factors that you need to take into account when you're laying up anything that you'll lose to the manufacturing process. And it'll also give me a weight and cost for my as-built structure. Okay. Good, so final analysis. We saved 52%, so that's a pretty good saving. That probably took me about an hour to set up. So a very quick way to analyze and compare two different solutions, the aluminium to the composite solution. Carbon fiber can be fairly more expensive. We also have glass fibers in the CMDB database, so you can have a look at how that compares compared to the aluminium by doing a bit of a sensitivity study. So there's further optimization that can go there. where, for example, if I wanted to change from infusion to pre-preg processing, I can do that very easily by comparing those material properties. Okay, so let's try to provide a short summary. So CompoSIDE allows for a very efficient and comprehensive workflow within design and analysis of both metallic and composite structures. There's a number of modules dedicated to each of the main design steps. So CMDB stores information about our materials and plies, physical and mechanical properties. Sorry. It can be stored there and used within all the projects automatically. Pricing information can be added and picked up from the later modules such as BOMGen for the bill of materials generation. So Laminate Space is a laminate design module based on extended classical laminate theory, and it allows the design and evaluation of various laminates within the project. Section Space we didn't touch on, but it's the beam modeling and 2D sections drawing module. Within Section Space, you can import or generate 2D sections and perform first principle analysis of your structures. And then FE Space, which we went into, is a dedicated 3D modeling and FEA module. You can import files or generate your own within FE Space, automatically generate and mesh for linear, modal, and buckling analysis. And finally, BOMGen, which we didn't really touch on, is the automatic bill of materials generation module, automatically calculating weights, stiffnesses, and costs for the structures. The integrated approach allows upstream modifications to be propagated downstream in the project, making it easy and quick to perform multiple optimization loops. So if you remember some of the questions that we posed, Sam posed at the beginning of the webinar. So which materials should I use? CMDB is the main key in this. You can compare the materials directly with each other in terms of cost, stiffness, weight, and strength, getting a direct comparison between all of those. So these material properties are available in our CMDB add-on, which is where you get our 1200 plus materials properties. How should I orientate my fibers and plies? So the quick optimization loops within CompoSIDE allows you to very quickly make small modifications and understand how orientating the fibers and plies really makes a difference to your structure in terms of cost and weight. And how can I compare total material quantities? So BOMGen automatically provide costs and weights, which comes from CMDB and your analysis. So that puts 2 and 2 together, taking into account any manufacturing factors, usage and wastage that you may have in real life.
Cool, thank you, John. So our next topic is the availability of CompoSIDE. So the good news is that we offer a free 30-day trial from our website. Registration takes only a few minutes, as John mentioned, and so there's no software to download, and you can be up and running within 15 minutes. So the trial is an ideal way to replicate the workflow or even look at your own cases. And myself and John, plus other colleagues, will be available during the duration of your evaluation, so we can help carry forward your projects. And also this 30-day trials are useful if you have, say, a home build project, so maybe it won't last very long, so you can play around and get a rough idea of what you want to create. So with the trial, you get access to dedicated online help and support. So we also have video tutorials to get you started and a live chat function with support from myself and John and other engineers when you have problems. We've also got email support and a few frequently asked questions with webinars and other sort of resources like that. And finally, we also offer online training, or on-site training and bespoke engineering services. So just let us know what your objective is and we'll be able to suggest some solutions. Okay, so we need to look for some questions.
Let's see if we've got any. Okay, so we've got our first one. Do you provide material properties for CompoSIDE users to use and design with? Sam?
Yeah, so with the free trial, I think there's about 60 materials to begin with, which is a range of different, so you've got different plies, different cores. I think there's some metallics in there. And this gives you a good basis to begin to start from. With these, you can then start creating your own, and you can use these as reference materials to then, say, create your own materials from these. But obviously, if you have your own materials, you can also add these into the database and begin with those. Hopefully that answers that.
Okay, just to remind you, there is a questions box in the in your GoToWebinar panel. If we don't answer your question, we will try and answer it with an email afterwards. Okay, so another one, can you please explain the PlyGen usage and wastage factors in a little bit more detail? Okay, so I'll take that one. So usage factors are any factors of materials, say resin or fibers, that you may have not accounted for in your design. So when we're designing with a laminate, we assume that there's no overlaps, no ply overlaps, so it's unlimited width of fabric. Usage factors take into account the fact that we may have to overlap the edges of some of these fabrics. Some of this resin volume might get taken into the core, so that's accounted into the additional weight. And then we go on to wastage factors. So the wastage factors are anything that you lay up and then it gets trimmed or discarded. So there might be a 10% of the area strip around the outside of your panel, which then you cut off on waste. But that still has to be taken into account when you're ordering those materials. So it's quite a good way of estimating how much you're going to use and waste, depending on your manufacturing type, the ply type, etc. Okay. So you can also adjust these factors. We do give you some baseline factors which we have put together when we were designing the software. But these aren't set in stone. So if you have maybe a less efficient process, or you see that you're maybe more efficient than we have assumed, you can change these numbers and make it more personalized to your manufacturing processes. Okay. So on top of the webinars, we do provide YouTube tutorials, so you can visit our YouTube channel. There's quite a few tutorials on there, taking you from the basics to more advanced modeling, composite analysis. There are a few case studies. For example, bicycle frame. You can have a look at that on our YouTube channel. You can follow it yourself as well, so that's quite a good way of learning the software, and along with the webinar as well. Okay. If you have any more questions, please don't hesitate to drop us a line, and we can answer you back. Okay, so thank you very much for taking the time and joining us today. We hope to see you soon.
Thank you.